Hello, everyone. My name is Adrian Garcia,
And I'm Eli Bowles.
and today we will be presenting our solar weather prediction system. First, we'll start talking with our data.
So, what we have is a set of basically all the years and cycle numbers starting at the solar cycle 21. For reference, we're currently in solar cycle 25. And we have the list of the cycle number, start date, end date, duration, years, which has all of the years in the duration. So from when it, like the first year to the last, this one's going to be 11 years apart, so we'll have 11 years in it. And these are our dictionaries. And each have the 12 months in the year and an average amount of sunspots, the radiation storm count, and the max severity of any given radiation storm in the month. Both the radiation storm count, or no, the radiation storm count is just the count, while the average is the total average of sunspots in the month.
And perfect. All right. Now, speaking on the main data, we start by importing data and classes. We'll start talking about class as well. This is our class time, and we do an init function for the year and month, RPR for the time, and the EQ for that right there. All right. So beginning with the find percentage, this one finds a specific solar cycle and takes a percentage to get the total cycle. The next one loops through all the different cycles and kind of returns which one that you're in. And the risk label converts the storm count and the severity into a label between low, medium, or high that depicts the severity of the month that you're in.
So when we start off by printing in these two bars, we have basically a question whether or not the user is interested in a polar flight or worried about radiation. And so, or maybe they're just interested to learn about the solar cycle. So we start with the question, what do you want to know? And in the background, we have the list of the 12 months, so we can test that later on, and we'll get to that eventually. But we have the initial while loop, so while that's true, the user can input a answer to that question, either a solar cycle or a polar flight. And if the answer is not one of those two, it gets kicked back up, and they have to answer whether, again, solar cycle or polar flight. And once they answer one of the two, we'll start with polar flight. Then that let's see, go back up. Actually, I guess we'll start with solar cycle. So when it hits the solar cycle, it does that same kind of while true process. So if the input was solar cycle, then it lets the user to input a year and month. And so, however, there is a limit. The year has to be between 1996 and 2030. Granted, our data is between 1996 and 2008. So the 2009 through 2030 is the prediction part, which we'll get to later. So after you input the month and the year, the month is from that list of 12 months to check if the input is in that list, the code is breaks, and then we continue on to polar flight and solar cycle.
Right. And speaking on the initial years, if the time is less than 2008, it's going to be pulling directly from the data which we have right here. This section of the code doesn't actually do any predictions, since it's all the data can be found within the data class. But let's say it wasn't, and then else, it would start doing some arithmetic in order to kind of get that. You can see here it gets the time years, subtracts it by 2009, and divides it by 11 plus 24. In total, then it goes to rounding, average storms, finds the cycle, and then prints out the information right here. The same is done for the initial and solar cycle. If it's within the data that's already predicted, it just prints it out. And if not, It starts the cycle at 24 in the year 2009 and does just some math to get it information.
I'd say more on the math for that. So the interest for C year and Y start is the sunspot Y is the user input for year, and it's subtracted by 2009 because that is the first year which we do not have data for in already for. So this is going to be the process for gathering that data. It divides by 11 for normally solar cycles have a length of 11 years. This is actually why we limited our prediction between 2008 and 2030 because after 2 solar cycles, solar cycles are on average 11 years long, but they can actually vary in length. Some being 9 years, 8 years, to some being 12. And then the plus 24 is to simply start off the 24th solar cycle. So that's why in C year we have minus 24 because that gives us the percent completed.
And now we can start with the test. It asks us if we're interested in polar flight, but worried about radiation, or if we're eager to learn about the solar cycle. Let's start with polar flight. Or first, let's start in case we didn't write polar flight. As you can see here, I spelled it wrong. It asks us to please input it again. This time I did it correct. Now it asks us for a year in between that range. Let's say we wanted 1900, which is not in the range. It gives out an error. Let's say above that. And it does it again. So now let's do 1980. Now it wants the month of the year. Let's do Jan. And there's the information. Starting that over again. If you want to learn about the solar cycle, it wants the inquiry between then. Say again, 1900. And then 3000. Let's do 1980. Jan. And then it gives us a little bit of information, followed with the cycle, average sunspots, radiation, max severity, and percent of solar cycle. But we can also do solar cycle. Let's do 2029. And then let's just do May. And this is our prediction. All right. And that about covers it all. Anything else to say?
That's all I got.
All right. Well, thank you very much for listening.